Okay, so we are tackling this topic on limiting a function, and then we are on infinity function. So given that a rational function f of x, okay, a rational function f of x is equal to, let's say, h of x over g of x, like this, okay, and then the limit as x approaches infinity is written as, so we have the limit as the limit as x approaches infinity, we write it this way. So the limit as x approaches infinity, like this is how we write it. So what that we're going to say, that the limiting value is determined by first dividing through both numerator and denominator by the variable with the highest power of x. So dealing with infinity, and then we actually be talking about rational functions, and then this is actually how we define the infinity in terms of limit. So we say x approaches infinity, and this is the function. So if the question is given, all that you need to think about is looking for the denominator and the numerator. Look for the variable with the highest degree or the highest factor, the highest power, and then you divide the numerator and the denominator by that variable. Okay, so let's take example here, and then I think you understand it better. Okay, so example like this, the limit x approaches infinity, and have 2x squared minus 3x, like this, all over 3x squared minus 2. So all that we need to do here is that we look of the highest power of x, the x with the highest power, and is x to the power 2, or we say that the variable with the highest degree, and is x to the power 2. So we divide the numerator and the denominator by that variable. So what we're going to do here is that we divide square here by s squared minus 3x by s squared all over, come here, and then we divide here to 3s squared by s squared minus 2 by s squared, like this. Okay, so with this we are to go. So you see that s squared cancel s squared, left with 2 here, minus s will cancel s squared here, left with x on as a denominator, so I have 3 over x here, all over s squared will deal with s squared, so left with 3 here, minus 2 over x squared, like this. And then we know that the limit as x approaches infinity is now 2 minus 3. So let's substitute x, or replace x here by the infinity. So by infinity here, all over 3, 2, and then infinity here square. So we know that any number divided by infinity is 0. So we're going to get 2 minus 0 over 3 minus 0, and the answer will be 2 over 3. So this is how we deal with infinity questions. Let's take the last example here on infinity and see how we can also solve it. You have limit as x approaches infinity here, and you have 4s cubed minus 5s squared all over 2x squared, no, 2x cubed rather, 2x cubed, and then plus x here. So all that we need to do is that the highest degree here is s cubed. So divide the numerator and then the numerator by what? S cubed. So get 4s cubed all over s cubed here minus 5x squared all over s cubed all over 2x cubed all over x cubed plus x all over x cubed. Simple like this. Okay, so our s cubed will cancel s cubed here. It left with 4 here minus s squared will cancel s cubed here, and then left with x as a numerator. So we're going to get minus 5 over x here all over s cubed. We deal with s cubed, so left with 2 minus this x cancelling here, left with 1 over x squared here. Okay, so now the limit as x approaches infinity, let's substitute or replace x here by infinity and replace the x here too by infinity. So you're going to get 4 minus 5 over infinity over 2 minus 1 over infinity square. Okay, so you're going to be 4 minus 5 over infinity all over 2 minus 1 over infinity square. And then because infinity is a very large number, divided by this 5, we're going to give 0. Okay, so getting 4 minus 0, and then here it means that 1 over infinity square, a very large number square. So divided by 1 give it 0, so you're going to get 2 minus 0 here, and again get 4 minus 2, and answer is definitely 2. So this is how we deal with infinity. When I want to deal with infinity, find a limiting value of infinity. So thank you for watching, and then subscribe to my channel for more tutorials. Thank you.